Hello. Today I want to talk about how to perform a k-means clustering analysis as part of our machine learning using R series. Okay. First, an overview of k-means clustering. So it is a unsupervised learning algorithm used to partition data into k clusters based on similarity. And it works by iteratively assigning points to the nearest cluster centroid, then recomputing the centroids. Minimizes within cluster sum of squared distances, also known as initial. Okay? And assumes clusters are spherical, evenly sized, and linearly separable, which may not suit all data sets. It requires the number of cluster K to be chosen in advance, and often guided by the elbow or the cell hotel method. And it is sensitive to initial centroid positions. Usually we use something called k-means plus plus to improve initialization. So the k-means plus means is a smart way to initialize the starting centroid for k-means clustering. So we pick the first centroid randomly from the data, and then pick each subsequent centroid with probability proportional to its squared distance from the nearest centroid, and repeat until you have k centroids. And I'll show you how to do that in R later. And k-means clustering scales well to large data sets due to its computational efficiency. So it is a pretty good knowledge discovery exploration method, okay, for large data set. Okay, so let me show you how to do it in R. Set random seed, create a data set. First cluster one is a tight spherical cluster. So you can see the standard deviation is small, 0.3. Second cluster is elongated, allocated cluster correlated. Okay, so basically we call mask MVR norm, the multivariate normal, and we get the correlation coefficient between the two random variable to be 0.8, so highly correlated. And cluster 3 is a diffuse and noisy cluster. So now you can see the standard deviation is 1.2 and 1.3, so larger than 0.3. 1.2 and 1.5. Okay. So we combine them together, and this is what the data look like. We can plot it out. So roughly, you got 3 clusters in there. Now we can perform k-means clustering. First, we need to determine the number of clusters. So in here, let's just assume we use 3. And then we use the k-means function and k-means data, and centers equal to k, and start equal to 20. So centers equal to k tells R to use k cluster centers. Okay. And since we already assigned 3 to k, so we're telling R to start with 3, use 3 cluster centers. And n equal to 20 is the kind of k-means plus plus, the smart way to initialize. So basically what this is it's gonna run the algorithm 20 times with different starting points. K-means will automatically select the solution with the lowest total within cluster sum of squares, so the best fit. So it actually does a lot of computation, but I mean, you can see the k-means function took no time to complete it, the cluster analysis. So that's why it's computationally efficient and can be used on large data set. Okay. So if you print out this object, you can see this information. It tells us it did a k-means clustering with 3 clusters, and the cluster size is 99, 142, and 129. And we know the exact sample size are not these cluster sizes, so there are mislabeled data points. Okay, and you get cluster means in the 3 clusters, and the membership, the clustering vector, tell you the data like for exactly one data point which cluster it belongs to. And you have the within cluster sum of squares by cluster, so they're minimized by the algorithm and also computed. And of course, you can ask for the cluster membership by using km at cluster. And also, you can plot out the data points, and you can add the center. Okay, so these are the clustering with marked with different colors. Okay, and of course, you can inspect the outputs. Km is a list, so it has all this information you can extract. Okay. All right, the next step I want to show you running k-means clustering using different initialization methods. So in this k-means function, there are four initialization methods. And I'm going to show you here. Here I added the iter.max equal to 50 because the default is the maximum iteration is 10. And for some of these options, they did not converge. So I increased to 50. So we can run these four clustering is four different initialization method. So a little bit information about the initialization method. The Mardigan 1 is the default algorithm. It uses a pairwise cluster reassignment method, and it tends to lead to smallest within cluster sum of squares. The smaller the within class sum of squares, the closer the points in the same class stick together. Okay. And this option also make it a convergent, the clustering converge fast, and it is widely considered to be the best. That's why it's the default. Okay. And the Lloyd method is the classic means, k-means algorithm. It recomputes centroid after each full assignment step, so it's slow. You usually have a slower convergence and may stuck as the suboptimal solution. So we use it here just for comparison purposes. And the 4G it sets initial centers by randomly selecting actual data points. And then the cluster assignment algorithm is similar to Lloyd. And it tends to create a stable and well-separated initial clusters. And so usually it's the classic initialization method. McQueen is really, it uses online or incremental updates, updates the centroid after each data point is reassigned. So instead of waiting for all the assignments to complete, so it is really, or it can be sensitive to the order of the data points. So it is really suitable for large real-time streaming data. Okay, so to keep that in mind. So we can print out the within the total within sum of squares. You can see they're mostly the same. So in this data set, the third one, the 4G has a little bit different, it's a bit smaller. But we in this simulated data set, they don't show much difference, but they can be very different for certain data sets. Okay. And also we can I can show you the effect of random start. So then start equal to 1 or 20 or 50. And then we can print out the total within some squares. And unfortunately, for this data set, they're not very different. So it's not a good demonstration. But for some data sets, they will be different. Okay. All right. Yeah, you can find an appropriate k value using the elbow method. So I'm just going to demonstrate that. So you create this WSS and calculate from 1 to 10, and then you plot it out. It looks like that. So it's really subjective. We pick like k equal to 3. You can say I want 5 or 6, or maybe 5, but this is sort of like factor analysis, so it's not clear cut. You have to put in some subjective judgment here, so it's not exact science. All right, this is a very basic introduction to k-means clustering, and if you have a really large data set, this basic k-means function may not work well, so you have to look for other more computational efficient methods for larger data set. Okay. Thanks for watching, and I'll see you in the next video on machine learning using R.